Hello, hello and welcome. It's your host nino-ani, coming at you live. Well, we're not live. It's a recording. Anyway, today is September 5th, 2025, a fantastic Friday. Did you know what we do on Fantastic Fridays, right? We dive into the archives to pull out a trending paper that's making waves. Today we're talking about something super important that's getting a massive upgrade thanks to AI. Hearing aids. Let's get the formalities out of the way. The title is Non-intrusive Intelligibility Prediction for Hearing Aids. Recent Advances, Trends and Challenges. The curl is Tax Organoxide Oil 9.3017 vol. It's long. Okay, so let's break this down. What's the big problem this paper is trying to solve? Imagine you have a hearing aid. Its job is to make speech easier to understand, right? But how do we measure if it's actually working well? Traditionally, you'd need a bunch of people to sit in a lab and listen to recordings through the hearing aid, and then you test how many words they understood. This is called a subjective test, and it's super reliable. But oh my gosh, it's also super slow and expensive. The other way is to use computer models. But the classic ones needed a perfect, clean recording of the original speech to compare it against what the hearing aid puts out. That's just not practical in the real world. All you have is a noisy, messy sound from the hearing aid's microphone. So the challenge is, how can we predict speech clarity without a human listener, without that clean reference audio? That's what non-intrusive means, and that's where this paper comes in. It's all about using deep learning nino-ani to create a virtual listener, an AI that can listen to the audio from a hearing aid and predict with pretty amazing accuracy how well a human would have understood it. This is a game changer for developing better hearing aids. So how does that actually work? Well, the AI needs two key pieces of information. First, it needs to understand the person's specific hearing loss. This is done using audio. Think of an audio measurement as a chart that maps out which frequencies, like high notes or low notes, a person struggles to hear. Some of these AI models take this audiogram information and just stick it onto the sound data, like a label. Others do something even cooler. They use the audiogram to run a simulation, basically processing the sound so the AI hears it, in the same way a person with that specific hearing loss would. It's like giving the AI a pair of virtual dead ears. Second, the AI needs to be really good at understanding speech itself. They can't just look at raw sound waves. So researchers are using powerful pre-trained models, like Whisper, which is the same tech OpenAI uses for transcription. Because Whisper has been trained on a massive amount of audio from the internet, it's incredibly good at picking out the important acoustic and linguistic hints in speech, even when it's noisy. It gives the AI a huge head start in figuring out what's being said. Then you combine these things in a smart model architecture, like a voice thing, and even a transformer, the same kind of architecture that powers that dict. The result is a system that can predict speech intelligibility for a specific person in a specific environment. Speaking of which, that reminds me of the joke. Why did the audiogram break up with the sound wave? Because it felt like it was only bringing up its past thresholds. Thresholds. Hearing thresholds. Yeah, okay, moving on. So where could we actually use this technology? The applications are seriously cool. Let's think of 3 examples. First, in the world of music, where someone with hearing loss, listening to music can be tricky. The lyrics might get lost, or the instruments might sound muddy. With this AI, a music streaming app or even the hearing aid itself could analyze a song and predict which frequencies need a boost to make the vocals perfectly clear for a specific hearing profile without making the instruments sound terrible. You could create a personalized dynamic equalizer for music lovers. Second, let's talk about voice technology and smart assistants. You know, Alexa, Siri, Google Assistant. Their voices are designed to be clear for people with normal hearing. But for someone with a hearing aid, it might still be hard to understand. Device manufacturers could use this AI as a virtual tester to design and fine-tune new voices for their smart speakers and phones, ensuring they are crystal clear for users with a wide range of hearing impairments. This makes technology way more accessible. And third, for all you gamers out there, in competitive online games, clear communication is everything. You need to hear your teammates instantly. This tech could be built into gaming headsets or software like Discord. You could listen to the voice chat, and in real time, assess and enhance the audio based on your Jiraujapun. So you never miss the critical warning about an enemy sneaking up behind you. It would be like giving your ears a competitive advantage. So, how does this compare to what we had before? Like I mentioned, the old methods were mostly intrusive. They needed that clean, perfect audio file for comparison. Think of it like grading a student's essay while having the original perfect essay right next to it. It's easy to spot the differences. These new deep learning models are non-intrusive. They're like an experienced teacher who can read a messy essay, and just from that, can tell you how good it is, without needing to see the original prompt. It's a much more realistic and flexible approach. But of course, there are still challenges. The biggest one is generalization. An AI might get really good at predicting clarity for the 25 people it was trained on, but then perform poorly for a new person with a different type of hearing loss. Making these models robust enough to work for anyone, in any environment, with any hearing aid, is the next big hurdle. Researchers are also trying to design better ways to train the AI, using objective functions that are more aligned with how humans actually perceive clarity, not just minimizing a simple mathematical error. So to wrap it all up, this paper gives a fantastic overview of a field that's moving at light speed. We're going from simple models to incredibly complex AI systems that use things like simulated hearing loss and huge pre-trained language models. The goal is to create truly smart hearing aids that don't just make sounds louder, but make them truly intelligible. And that could radically improve the quality of life for millions of people. It's awesome stuff. Alright, that's all the time we have for today. Thanks for tuning in to this trip through the archives. And then, well, I'll catch you on the next one.